Alright, welcome to another video. So today we will be looking at internal workings of Array.prototype.filter. Now every time I go online and look at the internet forums or Q&A boards like Stack Overflow or FreeCodeCamp forum, I see a lot of questions regarding this particular uh, concept in JavaScript. Like, how does this filter method works? It takes a function as a parameter and it returns a value, and I don't see how it is being iterated over and how the values are calculated and how it determines whether to keep the value or remove the value. I simply don't understand that. So if you have that kind of questions, then this is the video for you, because we will be implementing our own filter method, and then we will be looking at how to expose your own, like the method filtering method that we develop on the array.prototype. So before we get into anything related to prototype or how the callback functions are working, first we have to look at how to filter this array in a traditional way, like writing the code on your own. How to filter this array. Now what I want to do is I want to iterate over this array, and I want to create a new array that only contains even numbers from this array. So get even numbers from the array above. So how that can be done? So typically what we do is we write a function. So let's say function get evens, and we pass that array as a parameter. So if I do console.log arr, and then of course I have to call the function evens is equal to get evens array, and then of course console.log evens. So as the first thing, we'll get this the array that we pass to this function. Now the simple thing that we do is I want to construct a new array, so I will create one new array called filtered, and initialize with an empty array. And of course we have to iterate over the array for where I equal to 0, I less than arr dot length I plus plus, and then where should keep is equal to arr of I mod 2 equal to 0. Now this is how we determine whether element, like the current element arr of I, is even or not. We just use the modulus operator to identify whether there is no remainder. So let's not get into details about this, because that is not a point of the video. And then if should keep, then filter dot push arr of I, and of course when the loop is over we have to return the filtered. Okay, and if I run this, now I get 2 4 6 8 10. So our function is working perfectly fine. Now I want to get odd numbers, so typically what we'll do is create another function get odds arr, and then I'll just copy paste this code, because we essentially do the same thing, and I'll just modify the condition. Instead of checking for 0, now I'll check for 1, and then where odds is equal to get odds array, and of course console.log odds. So now we get odd numbers in one array and even numbers in odds array. And at the same time, if I do console.log array, which is the original array, you will see that it remains unaffected. So it is not changed. So that is how we want it. We don't want to mutate the original data. Now I want to filter that array based on whether the element is completely divisible by 3. So I'll essentially do the same thing, copy and paste, get what's going on? Yeah. Get divisible by 3, and I'll change the condition to match the output that we want, where divisible by 3 is equal to get divisible by 3 array, and of course console.log. Now we'll get one more array that has uh, 3, 6 and 9. Okay, now I want to filter this array based on whether the element is divisible by 5. So are we going to add one more function? Like, is that the best way? Like, we can have infinite number of conditions that we can filter the array based on. So it's not practical to add a new function each and every time uh, we discover some new filtering condition. So that is one problem. And second problem is, if you take a close look at these functions, like 90 to 95% things in these three functions are same. The only thing that changes is this condition. Like, how value of this should keep variable is evaluated. Apart from this, everything else is the same. So we have to find out a way that we can convey this function that this is the condition you want to evaluate. So to do that, what we'll do is we create a new function. Okay, sorry. And just call it filter, and it takes array and condition, and this condition uh, should be evaluated here. Now how do we convey this condition to this function? So if we understand correctly that we want to avoid the code repetition as much as possible, we want to reuse the code as much as possible, and we just want to pass the things that control the behavior of the function on runtime. So how can that be done? So what this condition should be. Now if we look at this get events function, this is the condition that we have. The current element mod 2 is 0. So if I try and call this function like filter arr and just paste this condition, and if I try to run this, this is syntax error straight up. Like, there is no question, this is not right. So how do we convey this condition to this filter function in such a way that it can be evaluated at runtime? Now, here's the important thing. As long as we are talking about programming and computer science, whenever you hear the term evaluation, the only thing that can be evaluated is an expression. And luckily in JavaScript, every function can be expressed as an expression. Okay, so the best way that we can do is we can pass a function as a second argument, and we call that function here. And this function should return either true or false. That will determine whether to keep the current element or not. Now how can this function be implemented? So I'll just pass in condition fn. Let's define this condition function condition fn, and I'll just say console.log condition fn called. Now for now, let's just comment this out and see what happens, and we'll just comment this part as well. So now we are only dealing with these three things. And I'll paste it here. So this is the code that we are looking at right now. So if I run this code, I should get condition fn called 10 times. ARR not defined. Oh, sorry, array. Right. So we see this condition fn called is logged 10 times because we are calling it inside a loop, and there are 10 elements in the array. That's why this function is called 10 times. But this doesn't really solve any problem. We are not able to identify whether to keep the element or discard the element. So to be able to do that, this condition fn, this needs to know what is the current element that is in the loop. So in other words, we need to be able to access this ARR of I inside this function. So how can that be done? Like how can I get some variable that is inside this function into this function? Well, it's simple. You pass it as an argument to the function. So ARR of I will be passed as argument, and we will catch it in condition fn, and I'll just refer to it as item. And if I do console.log item, then I'll see 1 2 3 4 5 6 7 8 9 10. So that way we are getting, well, let's just format this output a little bit. So I'll say item is, okay, so item 1, item 2, item 3, item 4. Now there are certain scenarios where we also need to access the current index of the iteration. How can we do that? The same way that we gain access to this ARR of I, the same way we can gain access to the I, the current index, and we can refer to this as index here. And let's just log item is at index $index. Right. Now there are also other scenarios where I want to be able to access the actual array, the original array that was passed to this filter function. So how can we do that? The same way we gain access to current item and current index. I'll say just ARR, and I will catch it here as original, and I'll just format the output in a bit different way. So dollar original dot join, then index dollar index is dollar item. So array, this is the array, and at 0th index we have 1. So this is a bit just a formatted output. So what we learned here is this condition fn that we have passed here is receiving each and every element in the array in loop. So every time a loop iterates, the condition function is called, and the current element in the iteration is passed as an argument to this condition function. So if that is clear, then rest of the things are very simple. So we have access to the current item, current index, and original array. But right now we are just trying to filter out the array based on whether the element is even or not. So we don't need these two arguments, so we'll just ignore them. But we will pass them anyway because we want this filter function to be generic. We don't need it right now, but someone, when you expose this library to other users, they might want to have access to those variables. So we'll just keep it there, but we will not consume them. And and as we can see here, this should keep variable. So value of this variable should be kept to be boolean. It should be either true or false. So it is now responsibility of this condition function, which is passed as a second argument to filter function, which indeed is this condition fn. So it is responsibility of this condition fn to return true or false. It should return true if the item satisfies the condition that you want. Right now what we want is we want to return true if item is even. So what we'll do is if item mod 2 equal to 0, then return true, else return false. And then we'll uncomment this part, because if the should keep is true, then we should be pushing that element inside the filtered array. Okay, so let's say var out is equal to filter console.log out. Great. So if I run it, I should get output as 2, 4, 6, 8, 10, and boom, it is working. Now we can do the same thing for odd. So let's rename this function as condition fn. Instead of condition fn, let's call it is even. Then function is odd item. Function is divisible by 3 item, and then we'll just modify these conditions to match our expectations. Excuse me. And let's uncomment this filter. And is even, is odd, is divisible by 3, and if I run, I will get the same output. So this is working perfectly fine. But now if we go back and look at the 3 original functions, we did not manage to eliminate the lines a lot, but that is not a concern, because we achieved the objective to take out the common logic out of all the functions and only provide the condition function that overrides the behavior of how the filtering is actually done. But we can still get rid of a lot of code here. First thing is we can replace this this if condition with a ternary operator, like item mod 2 equal to 0, then return true, else return false. And we can make these functions really small. Return item mod 2 equal to 1, true, false, and then eliminate this. And of course for this, return item mod 3 equal to 0, true, false. Alright, and if we run this now, we'll get the same output. And there is one more thing that you can do is, if you understand that every comparison operation in any programming language will ultimately give you a Boolean result. So we don't need this ternary operator. We can just eliminate that part and just return the output of the condition. Now if I run this, I'll still get the same output. So instead of doing this, now we end up with this. So what we achieved is we were able to override the behavior of this filter function based on the condition function that we pass as an argument. So we now have a generic function that can be easily maintained. The one advantage of doing something like this is that, let's say there is a requirement that we don't want, like if this is the array, I only want to iterate over uh, the first 5 elements, not the entire array. So if we are going to follow this approach, then I have to change the condition at 3 times, at 3 places. Okay, so arr dot length dot 2. I just want only the half array. Parse int, and of course I'll have to change the condition here. Parse int by 2 by 2. Okay, so what this problem is, this is known as a code that is hard to maintain, because if you change something, that you have to propagate that change at multiple locations. But if we are following this approach, then this is the only place that you want to modify. Parse int by 2. As you can see, the entire array was not iterated over. So the code reusability is one advantage. Right. Okay. Now uh, you can simplify this even more, but that is not that important for the context of this video. Is that you can replace these functions with arrow functions like item I mod 2 equal to 0, and we'll still get the same result. So this is how this pattern is working. Like, you are able to modify a behavior of function based on a controller function, not controller, like you can override the behavior based on some other condition. Okay, so having the with that said, this is not really what we want, because the original problem was that this is the array and I want to find only the even numbers in that array. But if we look at this signature, then it is not really very expressive, because first, this filter function we had to implement, that dealt with uh, the iteration logic, and it doesn't express anything. Like, if I say let's rename this to events1 and where events2, where we'll use that array.prototype.filter method. So what I'll do is array.filter is events1, events2. Okay, and these two methods give the same output. Okay, but if you look at this feels more expressive, because what it says is this is the array and we are going to filter the array based on this condition. Here we are saying filter this array based on this condition. So it's not really very expressive, and it's not very stylish. So what we can do is, like, that is not the only reason. The performance is another reason, but we are not going to get into it, because this is the video that is targeted towards the newbies, and newbies tend to write code that looks fancy. Okay, so now I want to be able to call my function, this filter function, from array.prototype. So how can we do it? So first, let's define array.proto, sorry, and let's call it my filter. Let's assume that we don't want to use this filter, the native filter. We did some performance optimizations and we proved that my filter function is much better performant. So we want to use this and not the native prototype function. So we'll just say array.prototype.filter equal to filter. Sorry, my filter equal to filter. and let's clean up events, and let's uncomment this. Okay, so we will call it as array.myFilter, and it takes only one argument, array.myFilter. Again, one argument, array.myFilter. Oops. And only the callback function as an argument. If I run this, it is going to fail because this function expects first argument to be array, and we are passing first argument to be a function. But we are not passing this array because we are calling the array.prototype method. We already have access to this array, the array on which the prototype method is called. In other words, the object on which you call the prototype method is available as this inside your implementation. So we don't need this array here because the value of this keyword here is going to be this array. So we are going to replace all the instances of ARR with this, and this. And if I call now, what happened? Oh, sorry, this. Boom, we got the same function. So if we are going to compare these three with the native prototype filter, so let's say evens 1, odds 1, divisible by 3, 1, evens 1, odds 1, divisible by 3, 1, and let's replace my filter with filter, and we should get the same output. Boom. So we learned that how this paradigm came into being. The first problem was there was no way to override behavior of a function, uh, and that resulted in lot of duplicate code and lot of code that is hard to maintain. So that is what we learned. So to solve that problem, what we did was to extract the common logic into a wrapper function, and the code that is responsible to change the behavior of your function is passed as an argument to your wrapper function. This paradigm is usually called in computer science terminology as abstraction. So what abstraction means is to hide the implementation details. Now what does it mean to hide something? Because I can look at the code and I can see that how the code is written. So it is not hidden, but that's not what it means. Hide means hiding implementation detail. It means when I look at this line, all I'm concerned with is array and the function that filters the array. I don't have to care about writing the loop and iterating over the array and how to start and stop the iteration, where to start and where to end the iteration. I'm not concerned with it. The only thing I'm concerned with is the array and how I want to filter that array. So what we essentially did is we abstracted away looping logic and we provided the filtering logic. So that's what it means to have abstraction. Alright, so that is all for today. So stay tuned for the next video, because today we looked at filter and tomorrow we are going to look at, like, not tomorrow, like in next video we are going to look at the map operation. So array.prototype.map is what we are going to look at tomorrow in next video. Then probably I'll do some video on reduce and find or find index or something like that. Yeah, but they all follow the same paradigm. Like, by the end of this video, if you understand how this is working, like how this is even function receiving each and every element from the array, and you're clear on what is going on when you look at line number 52, 53, 54 and line number 74, then you're good. Like you can understand a lot of code just by looking at it. Alright, thank you for watching. Stay tuned.